stressful or not be shuffling too many things either once the session starts. It's 15 minutes presenting. I'll give a warning, I'll try waving, not everybody looks at our direction all the time, but I'll try and signal that there's 2 minutes left so that you have an indication of where you are in the presentation. And then we have time for the jury questions after. And it's great to get questions from students as well, so if you have any questions, we will offer them to you probably first and then the jury. So we have.
Are we going to be interrupted after 15 minutes, or are we going to be able to finish?
Normally we would, if it starts to go a bit too much, I'll probably stand up and you need to cut. I mean, it needs to be 15 minutes, not 17 or anything. Yeah.
Just one minute.
I might be finding a good Yeah. Okay, so we have 3 speakers in this session, Daniel, Lais and Gabrielle, and we're going to have Daniel first. I think we're ready to start. We're all ready. Streaming's ready? Yeah, everything's going great. So I'm delighted to introduce Daniel as our first speaker, who's going to talk to us about Magellanic penguins. And without further ado, I'll pass it over to you. Good luck.
Thank you. First thing I want to say, my colleagues didn't know me, maybe I'm also, yet. So I'm a stutterer, so if you see that I struggle with any word, I'm nervous of course, but it's because of the condition. No? Having said this. Okay.
Yeah.
Okay. Good morning. Good morning to everyone. My name is Daniel Faura, and I'm going to defend my thesis on the foraging energetics of the Magellanic penguin, my first case study in the subantarctic region. This will be our index. I'm going to start with a little bit of a background, followed by the objectives, methodology, results, and a bit of discussion that will come all together at the same time, and we'll finish with some conclusions. Starting with the introduction, we first must say that animals' distribution over space and time is not at random, like in the first image in here, but it normally follows certain distribution patterns, like in this one, which are based in a complex decision-making process that includes factors such as resources distribution, predation risk, social interactions, and many other factors, but the most important in them is foraging strategy. In fact, this foraging strategy is the one that led to the optimal foraging theory back in the 80s that states that the animals that are the better adapted are the ones that maximize their energy gains and minimize their energy expenditure while foraging. So, although this theory led to very important advantages in the field of spatial ecology, with time it has been considered an oversimplification because it assumes that the energetic cost of the animals moving under laboratory conditions are the same as the energetic cost of the animals moving in the natural environment, which now we know is not the real case. In time also, this oversimplification led to a new theory in 2012, the energy landscapes ones, that states that the physical features of the environment are the ones that actually can shape the foraging behavior of the individuals, which would be linked ultimately to their fitness and which can be used to predict their population trends. Having said that, we jump to the main characters of our study, the penguins. They are one of the major consumers of marine resources in the southern oceans, and therefore they have a big impact on the ecosystem's energy flow. That's why they can be considered good value indicators of the Southern Ocean ecosystem health. And it's important to know both their foraging strategies and their feeding hotspots. Now, to conclude with this part, you may have noticed that the background of the slides is an actual map with some penguins on it. Well, it is Martillo Island. It's a place that has hosted a large number of studies on both Magellanic penguin and hen-tooth penguin, but none of them yet on the foraging energetics. So it's this gap of knowledge that motivated our objectives. The main one is to have better understanding of the foraging distribution and energetics of the Magellanic penguin breeding colony of Martillo during the last decade, but the more specific ones are 1, to use accelerometer data to estimate the foraging energetic cost of those penguins. Second, to create a model that allows us to estimate those costs, but based only on GPS datasets. Third, to map all the GPS data the Institute had from the last decade and to run the model on this data to also estimate their energy consumption. And finally, in a way to wrap everything up, to contextualize all this study by estimating the impact the penguin have of the ecosystems in the Beagle Channel by calculating an estimate of food consumption for the whole colony. So now let's dive into methodology. Let's start with the study area. We are at the very, very south of Argentina, one step close to Antarctica. This is Tierra del Fuego. More specifically, here we are on the Beagle Channel. Here we can see on the left part of the picture the capital of the region, and then our study site that is on the eastern part of the Beagle Channel, Martillo Island, as I said before. It hosts a breeding colony of Magellanic penguin of circa 3,600 active nests as per the last census of 2022. And it's a special site because it's the southernmost colony of this species that has ever been studied. Now looking into the fieldwork, back in December we deployed 16 accelerometers and 6 GPS loggers on breeding adults of Magellanic penguin during the early chick breeding period, which is when the chicks are less than 30 days old. And we took several data, but probably the most important for our study is the GPS location, pressure that allows for that, and then acceleration data at different frequencies. Also, upon retrieval of the devices, we took biometric measurements. And finally, we also included in our analysis the GPS datasets from 2014, 15, 17, and 22, also taken on breeding adults of the species during the same early chick breeding period. Now looking into the analysis, the first thing we did was to actually retrieve the GPS from the penguins, and from that we downloaded the raw readings of triaxial acceleration, which we used to calculate the overall dynamic body acceleration, which is this ODBA that appears here in the calculations. With that, we could make an estimate of oxygen consumption and finally energy expenditure. Regarding the second goal, I'll try to explain it with an example, right? So what we wanted to do is to create a model that allows us to estimate the energy expenditure of a whole trip between the colony in here and a certain point in the Beagle Channel, right? So what we did first was look into the diving part of this trip, and we defined the diving cost as the median dive time multiplied by the median diving energy expenditure, multiplied by the number of dives the penguin would perform from the colony to the certain location. This number of dives at the same time is calculated as a ratio of dives per distance multiplied by the distance between these two spots. We also had to look at the surface part of the trip that we defined just as the travel time between the two spots multiplied by the median surface energy expenditure. So now that we have the two parts, right, we are able to calculate the total trip energy expenditure, and it's as simple as 2 times the surface cost, because it's not only getting to the location but coming back to the colony, of course. And we also multiplied by 2 the diving cost, because when we looked at the depth profiles of the penguins, we saw that from the moment they left the colony to the moment they came back, they would perform dives during the whole trip. Regarding the third goal, we took this model and ran it on the previous datasets. And finally, regarding the fourth specific goal, once we had calculated the maximum energy expenditure per individual, we calculated the maximum energy expenditure for the whole colony, and then we could make an estimate of the colony food consumption for one trip. We played on 2 different scenarios. One where the colony would only eat bluefish, 100% of the diet is bluefish, and a second one where the bluefish would only represent the 50% of the diet, and the other 50 is divided between the lobster and the squid. So now diving into results and discussion regarding the first goal, I first want to say that we found the energy expenditure rates to be quite stable. Both looked at the instantaneous rate and to the hourly rate. Let's look first at the instantaneous rate. We found it to be between 0.7 and 1.4 joules per kilogram per second. And when we looked at the hourly rate, as in this figure here, at least for the first 12 hours of the foraging trip, we saw that the 75% of the data would fall between 3.25 and 4.25. Regarding the second goal, we have this beautiful table in here, but we only look at the two columns here in the right. The one in the left is the total energy expenditure calculated from our accelerometers, and the one in the right is the total energy expenditure predicted by our model, but for the same trips as in this one. As you can see, the estimates of both columns are quite similar, but we have three exceptions in yellow. This 84, 50, this 130, 13 with 58, and this 82 and 15, which is probably the largest gap, no, relatively. I'll try to explain these exceptions with this figure in here, but first let me say that the model was conceived for linear trips between the colony and the foraging location, in which the penguins would not stop in the middle and spend a certain amount of time feeding, but that fraction of time feeding would not be a large fraction of the whole trip. Having said this, we look at the first case, 16x5. We see that the penguin came to around 30 kilometers, then back to around 25, back again to some location in between, then back to the colony. So as we can see, we can determine at least 3 different feeding locations. So it's not the case what the model was conceived for. The second one, the 22x1, the penguin came to around 35 kilometers and then back to some place between 20 and 25 and spent a lot of time, large fraction of time. So again, not the kind of trips the model was conceived for. And the one with the largest gap, the 22x5, in this case, the penguin didn't even left the surroundings of the colony. It was a complete trip, a long trip, but it stayed always in a 10-kilometer circle surrounding the colony. Regarding the third goal, we actually did map all the GPS data from the previous years here in red, and we were able to run the model on this data to obtain maps of predicted energy expenditure. But the interesting thing comes when we compare the maps of predicted energy expenditure with the heat map of density of GPS points, because this allowed us to describe 2 new zones in the Beagle Channel. The first one here in yellow, which is the area the penguins would use them the most because it has the highest density of GPS points surrounding Picton Island, and a new zone of highest energy expenditure that would fall northeast of Nueva Island, and that is especially interesting because it's consistent over time. As we see here in all the maps, 2014, 15, 17, 22, 23, and the one I just showed you of all the years combined. In all of them, we have this yellow zone north or northeast of Nueva Island. Regarding the fourth goal, first let me say that we calculated the food consumption between 13 and 233 grams per individual per one whole trip. But when we look at the big numbers for the whole colony, first looking into the scenario where they would only eat bluefish, 100% of the diet is bluefish. For the 4 years that we had the numbers of the whole colony, it's consistently between, let's say, 500 approx and 800 kilograms per trip of bluefish. But when we look at the second scenario here, where the half percent of the diet is bluefish and the other half divided between the squid and the lobster, it is consistently above 1,500 kilograms of food per trip for the whole colony. I've also put here the nutritional values of all the per items, so you can kind of understand why the large column regarding the lobster. So now let's finish with some conclusions. First, regarding the first goal, we found, as I said, the energy expenditure rates to be quite stable. Both looked at the hour rate and the instantaneous rate per second. Regarding the second goal, the estimates that our model predicted were quite accurate when compared to the ones calculated directly from accelerometers, at least for the kind of strips the model was conceived, so these long linear strips between the colony and the foraging location without stops. Regarding the third goal, once we mapped all this GPS data from previous years and run the model on this GPS data, we could describe two new zones for the Beagle Channel. One, the penguins they would use the most surrounding Picton Island, and another one of highest energy expenditure, consistent over time, northeast of Nueva Island. And finally, we were able to wrap all this study up by contextualizing the impact the penguins have on the ecosystems of the Beagle Channel by making an estimate of food consumption per one trip for the whole colony. So in the end, we do have a better understanding of the foraging distribution and energetics of the Magellanic penguin breeding colony of Martillo during the last decade. I'll just finish with the references, the few references I put in the slides, all the other ones are here. And I would really like to thank you, my directors, Sabrina Harris, my supervisors, Andrea and Clemens, CADIC, which is the institute that hosted me all this time, and then to the Wildlife Conservation Society and the Antarctic Research Trust, because they gave most of the funding for this study. And also, all of you, for your attention.
So questions from the audience? Anybody have any pressing questions? Yeah.
This question about more the fieldwork part. I saw that for the fieldwork, I saw that you were all covered with like the white stuff and the gloves. Was it for avian influenza, I guess?
The study was designed to be for both Magellanic penguin and hen penguin, but just at the beginning of the breeding period, they found in the island one hen penguin, one breeding adult hen penguin with what it looked like symptoms of the avian flu. So they decided that for the whole year, for the whole breeding period, we wouldn't be working on the hen penguins. So that's also why we only focused on Magellanic. And although we did focus only on Magellanic, we would also wear like the mask and everything. When they were doing the field work of my thesis, which I could not do because I was in Norway, and because it was in early, like late November, early December, the picture I put of the penguin and the measurements, they're also wearing a full kit of protection.
And how did you get the data for the feeding?
For the feeding?
Yeah.
So the data for the feeding, it's based on many things. First, the aim was mainly to be illustrative as a way of contextualizing the whole study. The calculation of the feeding estimates have some limitations, but with it is, as I said, there are a large number of studies performed on the island, most of them on the feeding ecology and the kind of prey items they have. And the one I based the feeding estimates on is one that calculated first the amount of prey, the diversity of prey in the stomach content of the penguins. That's why we also played with the two scenarios, because this study said that during the early chick rearing, which was when we were playing, depending on the amount of bluefish, it would be between 40 and 90% of bluefish only the diet, and the rest would be the squid and lobster. But if there was a good amount of bluefish, and then for the late chick rearing period consistently, it's circa 100% of bluefish.
Thanks. Do you remember any questions?
First of all, Daniel, thanks very much for your presentation. It was very well organized, everything, and well explained, so well done. I was just wondering about Can you remind me again how many accelerometers and how
Yeah.
many GPS you put? Was it
Sure.
between 15 and 6? I wrote down, but I can't remember
Yeah.
if that was correct.
So what we deployed was accelerometers on 16 penguins, GPS on 16 penguins. This is only the ones we deployed in December. Here we have many more in total. I think it's on the thesis. I think it's about 50 loggers for the whole for the last decade.
Per year
Section.
or altogether?
No, for the whole last decade, it's around 50 loggers. But in any case, the accelerometers that were the new part of the study, we bought 8, and we did deploy it in 2 different the same period, like consecutive series.
Mhm.
There were 8 and 8. Yeah.
Okay. So the accelerometers was a new thing from
Yeah.
now, like now.
Yeah.
Okay. And were these penguins like? I mean, obviously they're tagged. Are these the same ones that they've been posting for the last few years,
No.
or completely random individuals that they would catch?
No, not at random, because one probably the best part of this island is that it's the only Magellanic breeding colony where they have the nest really located, like a fraction of the nest really located, so they know the exact age of some of the penguins that nest there, because we also put chips on all of the chicks every year. So, sorry, again, can you repeat the question?
I was just wondering if they were the same individuals, since they
Yeah,
should be
no.
tagged and things
No.
like that.
Since we have the actual age, or at least a minimum age
Uh-huh.
of all the penguins, we don't need them to be repeated over time. So as far as I know, for this season they were not repeated, and I don't recall, but I think no, they are not repeated from the previous year.
Okay. And in terms of just the last thing, in terms of diet, so with the diet studies that you're saying in this same colony.
Yeah.
Okay.
Yeah.
Okay. So
Simple.
for this same period.
Yeah.
Okay.
In fact, like they did a study for the Magellanics, since they are migrate, they are only there during the breeding period,
Yeah.
and a bit later, especially the chicks. So they did the estimates for the whole time the breeding adults would be there, and the paper shows that before, like during incubation, during early chick rearing period, during late chick rearing period, the percentages of that.
And what was the diet methodology? How did they study? Was it observation or
No, it was
regurgitation?
this one was stomach.
Flush?
Yeah.
Okay. Thanks very much.
No, I just want to comment that thank you for your presentation. It was clear, and I'm ignorant in the field, so it was quite illustrative for me. I only have some curiosities that have been commented around. I have one more regarding the composition of the diet and how it can influence the model you are doing, because you are considering the distance to the foreign ground and measuring, but I guess the energy expenditure would depend on the energy benefit when they are, and this will be different depending on the composition of the diet,
Yeah.
and it may change year from year. So it's an idea how can this be implemented into a more complex model, including other stuff.
Okay. Complex question.
The complex question is usually done by the people who doesn't know.
No. Good. I'll try to do my parts. First, this study, like the study I'm citing, is the big study on the feeding of this colony. First, what we saw is that it really changed a lot between years. Although we say it was doing early chick rearing consistently, the bluefish between 40 and 90, but 40 and 90 is like a large gap, right? Especially considering the very different nutritional values of the preys. So they did see this change, and they assumed this. That's why also we're working on the importance of the description of the new zones. They assume that is when since the sardines also migrate, they assume that because of weather reasons, climate change, I don't know, the migration comes late or there's not much abundance, they mainly feed on this load. But in case they do have this feeding resource, they really exploit it. And the two the two areas in here is where we think that the sardines would, like the feeding hotspots, especially this in here, because the one surrounding Picton Island is really surrounding. So this is the all years maps, all years combined, and it's quite, let's say, large area surrounding. But the one in here is surprisingly consistent. So this is what we thought. But the census, like the fisheries census they do, it only reaches, as far as I know, here, so just above no island. So there's a gap of information that we don't know what kind of food or the amount of food they have right over here.
Yeah, we have time for one more question.
I was just wondering, did you mention how long, or do you have an idea of how long these feeding trips were? Like, was it days? How many days?
Yeah, this is the part of the table I was keeping in the question. We don't have
I
time.
saw it.
Oh, hold on. These are the penguins we included in the analysis. We have 10 in here and not 16 because we had some failures on the axillary properties. So the N for the analysis for the model on this is 10. And it's also 10 because we had failures in 2 of them, and the other 4, they worked correctly, but they didn't record the whole trip. We wanted the whole trip. So based on this is the numbers of the whole trip, we have quite a large difference from, I think the largest is, longest one is 31:26, and the shortest one being a complete trip is 3 hours 31. Also meaningful is that the 22x5, this special guy in here, is the only one that recorded 4 complete trips during the period of time we were following them. It is less than 4 days. So this is quite shocking because we would not expect, like we would expect a long fishing trip around 1 day, like between the 20s and the 30s. We come back, stay a day, couple days there, then go back. And this was quite shocking. I must say I've not talked here, I've talked about males and females, I didn't have time here because it will also come in the next paper. But it's quite interesting looking at the differences between males and females, especially regarding the difference in maximum distance. Males would go a little farther than females, but females, what we saw that they perform much more nice. So these are all parameters. The R package we worked with was also super nice, had a bit of a limitation, but it gave you, I don't know, about 35 different variables regarding all the diving and trips. So we could really play a lot with that.
Yes. Do you know the age of this?
Yeah.
Can you relate the distance of the age?
This will also
An
come
idea?
on the, yeah.
Because the older would be shorter. I mean, the older we know we do shorter trips.
Yeah. We also did like analysis regarding age. They are not here because it's the next paper again. But what we saw, novelty, is that it's not that the younger ones or the older ones go farther or closer, because we assume it depends on the location of the feeding hotspot every year. But what we did see and was significant is that the older they get, the more straight was their direction of
The ways that they are.
yeah.
They know where they're going.
Yeah. So it's the most experienced first.
Yeah. Super. Well done again, Okay, so our next speaker in this session is Lais, and we're moving on to puffins. So over to you to introduce your work, and best of luck.
Hello, good morning everyone. Today Today I'll be talking about my thesis, which was under the supervision of Arsten Werk in the University of Bergen, Norway, with the title Seabirds as Ecological Bridges, Flux of Nutrients from Sea to Land by Atlantic Puffins, Fradicula arctica, along the Norwegian coast. So first I'll be talking a little bit about an introduction, and here we know that ecosystems, they are all connected, so they can exchange matter and energy and as well organisms. And for that, here we'll be focusing on seabirds and their role as nutrient vectors, because they feed on the sea and then they have the breeding colonies and they deposit the fecals, which is guano, and it's full of nutrients such as phosphorus and nitrogen, and I'll be focusing on that. The Atlantic puffin is a small seabird which is located only in the North Atlantic. They are very significant in Norway because it's one of the biggest amount of breeding pairs in the world. And here is a map of Norway and all its colonies. And for my study, I wanted to study the whole Norway, but here I will focus only on Hunde, Host, and Anda. They're very unique seabirds, as always, as all the organisms, but the population trends have been changing over the years, so I thought it was very important to see, and also because they don't have estimation of guano production for this seabird in Norway, so I want to look into that. So that's why the aim here will be to see what is the guano deposition in the Norwegian colonies by the seabird. And the research question is, I want to know the kilograms per year by each colony that they will produce in guano. My methodology, I first had to do literature research to find all the parameters to put in my model. And then I did an adaptation with a model from different studies that I could predict this guano deposition and the kilograms they produce. And I had to work with colony population data, and this is what I had a problem with my thesis, and I'm delivering it in the second deadline. And I had to do a simulation for the population. Here are my parameters, and some of the important ones for this is, sorry, it's the number, okay, the diet. For the diet composition will change between species, the flying speed, retention time, the adult body weight, and the chick. So these were some of the parameters that I had to find in literature. And here it's important to mention the daily energetic requirement that will be different from individual in the species. So the chick, for example, I would have to do exponential growth because they grow when in the colony, they grow in the days. So I did this explanation, and I also did sensitivity analysis to assert every parameter, what is the contribution of every parameter in the model. So to start in the model, I divided into two. The first is individual level, where I had to see the breeders, non-breeders, and chicks, the difference between their contributions for the colony. And first I used this equation, which is inspired in Frankish 2015. It is the guano deposition. And second, the guano deposition on land, because of course it's different, because the adults, they go feeding each day, the non-breedings and the breedings, but the chicks, they stay in the colony. So it will be different, and here I achieved from these three equations. Forward. As for the colony level, then I have to estimate the whole contribution, so the sum of all these three individuals, the non-breedings, the breedings, and the chicks. Individuals, for that I did normal distributions, and then to see the times of arrival, breeding events, and departing patterns of breeders and non-breeders. Some of the key components here, it's that the breeding population size will be different between the colonies here, and then it will change between colonies in the position. The non-breeding population I estimated as 6% of the breeding pairs, and the clutch size is 1 egg each couple, and the distance from the sea I consider as 100 meters, and all the colonies that I did, but will change. Here, we have to look at the axes that pay attention that they are different. For example, host has a lot of a lot of individuals here. And this I took data from 2013, and I had to simulate for the other years because I didn't have year by year, which is what I wanted to have, but I had to improvise. And because 1960 was the double, then I did the double from 2013, and then 2030, 2050, I did a simulation of less 30% and here less 50% than 2013. Here are my results, the individual level part, and we can see here that the daily guano deposition on land for breeders, 15, non-breeders, 1.14, and the chicks is the average because they contribute differently by day as they grow. Here I just wanted to do a representation of that. Here, because breeder and non-breeders are in average, and chicks, we can see the exponential growth of it. And here for the colony, that I applied the colony level in the model, and here I had these results of kilograms per year in Hunde, Host, and Anda, the colonies, and between the years. And here as well is the same thing with the X, it's different, and here is 500, 2,500,000 in Host, and it's just, if this data was applied in real data for colonies, of course this line would change a lot over the years because there are some years there are more breeding pairs and some years less. So this guano contribution will vary between the years. Here as the discussion, I wanted to compare my data with the Frankish results. They did with different seabirds, kittiwake, littlewhawk, and guillemots, and you can see that my data here, my results are different because they're much higher. And this could be due to Atlantic puffins being bigger. It's a bigger seabird than these two. And guillemots, it could be different because of the diet that they have, and also the guano, the excretion rate, it could be also different, and the feeding habitats as well as they go. It's also important that to consider the chick contribution, because chicks, in my model, I predict that they would survive, but then there will be years that they will not survive, and then they will be deposited, they will be dead, and their bodies will be on land, but this would also be a nutrient deposition. This could be important for inserting in the model, so it's just an autocritics here of my own work. Of course, the difference between the colonies, so the arrival, it can change through Norway because it's more north, some colonies are more south, so this could change over the years. The topography as well, so the inclination of land could change. This could be altering the results for the model. And of course the distance of the sea. And because Atlantic puffins can have different behaviors as in migration to go feed in the colonies, so this could also change. But the guano deposition here would be significant for the soil part and the substrates and plants and the pH of the area, so they're very important. And here I wanted to say that there is an article that was published that it was just all the seabirds in Norway and how they're disappearing through the years. And we can see there is two different, it's not Atlantic puffin, it's seagulls, but you can see in 2006 and 2013 the difference between them. So my study would help to estimate what is going to be the change in the guano and the vegetation. So I will see that over the years, if the population is less, it will be less also nutrient deposition, and then less interference for the plants and the vegetation. In conclusion then, the nutrient deposition is big compared to the other species in Frankish in 2015. There is a great contribution for the nutrients in the breeding grounds that they are situated. And of course, there's more data needed because my goal here was to see really the difference between the years and the colonies, but I had to do a simulation in this case, but at least now I have the model to work with once I have the real result for the colonies. So I can have more robust results. Thank you for your attention.
Excellent, well done. So questions from audience members first? If you have any, yeah, Daniel.
Yeah. Do you know what kind of like how they monitor the colonies, the 3 colonies?
Yes, they go on site and they monitor them
And do
on
you
site,
know,
and then they do estimations. But this data, I was supposed to get it, but I didn't get it
yeah.
because they don't have online available, and you try to reach all the Norwegians, and then even my supervisor couldn't.
So they are managed
Yes,
separately?
it's NINA Institute of Research that has it,
Yeah.
and in their website is not available to public the results.
Okay. And besides that, I'm just curious. Do you happen to know the cheap productivity of the locations?
Sorry?
The cheap productivity of each location. Do you have the numbers?
Yes.
Oh, yeah.
The chick, you said?
No, the productivity, like how many chicks they have each pair.
No, my model estimated one. It's always one per pair.
Okay.
Yeah,
Or 1 chick.
yeah. Per pair. So you do, but of course there are some years that some pairs they lost their chicks, and then this would be a data obviously important to consider. But it's just for my model, no.
Any other questions? No? Oh, yeah, go ahead.
It might be a dumb question, but so the populations are decreasing. Do you know what is the main factor that affects the decrease of the populations?
Some study says it's because of overfishing, and then they don't have enough food, and they feed on herring, and there's a crisis on the fisheries. So mainly because of that. Also some disturbance in the colony, but it's mainly fisheries and over not having enough food.
Do you think they would recover now that they are starting to banish the sandeel fishery?
Yeah, probably. Yeah, it's a tricky question, but probably. But mine was a simulation, so I don't know if it's gonna happen that in 2030, but it's just what has been happening through the years.
Okay, sure. Oh, yeah, one more. Go ahead. Yeah, we have time.
How did you decide for the model, say, you said like 50% of what the producer and 25%. How did you decide those numbers?
Looking literature, because I saw that in 1960 was the double, and then the predictions were that it was going to continue. So I did a bad prediction it's a negative prediction, as if what it was going to happen if this was 30% and then more 20% to reach 2050, getting the 50% less.
I just have one question because it's related to that, so I'm going to butt in. I was curious when you went through the literature and chose the parameters that you wanted for your model, how you chose which paper. Like if there was papers with, there's probably people studying similar things.
Some of them I did the average of yes, because a lot of them were different, so I had to work with the average. And also I mainly choose the ones in Norway.
Okay.
The studies in Norway, but there wasn't that many studies, so
Okay.
it was tricky to find. But I choose only the ones in Norway.
Okay, thank you. Yeah, one more.
Just a methodology. What did you use to model? R or
R.
Yeah.
Yeah, equations in R.
Okay. Yeah.
Okay, thanks very much for your presentation, I was just wondering, so you based your model on literature.
Yes.
Do you know what methodology was used to collect that data?
The data
For the amount of guano in the colonies for each species, for breeding, for non-breeding, for chicks?
Well, the model also the literature for the parameters. But it was mainly a lot of articles that would produce the small equations, and then I would add these equations to my model.
Okay, but don't you think it would be important to know what kind of methodology was used? How do we collect that?
Yes.
You don't know.
Yes, for the parameters. Yes. This would be written all the because they're all different. A lot of different articles, so it's a lot of different methodologies.
Okay. Do you have any idea of the main methodology that was used for that?
No.
Like as in which one was the main one? Like most research does like this.
Some of them it's modeling as well, and some of them it's going to the field, so in-field parameters and affirmations. For example, some of them are non-data. For example, the chicks and the weight of the Atlantic puffins. This is non because it's the study over the year, so it's just an average.
Yeah.
But yeah, of course, it's full of different methodologies.
Okay. And how would they be able to tell the breeders and non-breeders? Do you know that?
Because they don't stay, they go more. So it's just, I did a 6% because it's estimation, and then it's just an estimation of 6%. So we don't.
You estimate that 6% of that data is non-breeders.
Yes.
Is that?
Yes.
Okay. Okay. How do we take into account what's left in the sea? Because obviously they don't only so how do we take that into account?
Yes, because mine was just inland, so it was going to the sea. I didn't focus on, but of course it is taken care. But if you do my model in reverse, then you could find what is in the sea. Because I calculated for land, then you can also calculate it for the sea.
Okay.
Yeah.
Sorry, I just had a few more questions. Can you go back to that slide where you're comparing with the other species, please? So why do you think there's that difference for you? Because you mentioned size there, and I was a bit confused.
Yes, these two are very small, these two, and this one is bigger from Atlantic puffins. So what I only
a kittiwake is a fairly big bird as well. So I wouldn't
even
think
the
that.
black even this one because
the black ledge kittiwake.
The size was smaller in their model.
That's a fairly like big bird for especially in comparison with the puffin. Most people that have never seen a puffin, they think puffins are huge.
Yeah,
they are actually quite small.
Yeah.
And yeah, it would be more similar to a guillemot size, but even so if we are not taking into account the size here, what could we be taking into account?
It's mainly the feeding behavior. So they go more, they feeding more quantities. So they excrete more, and they stay more in land as well. But it's mainly the time that it's processed to deliver.
Okay. So just one more thing, just to wrap up. What does this mean in terms of conservation? So we know puffins are, their numbers are declining a lot. So what does it mean to find out like that?
Because I wanted to explain that in some way, in a different way, how puffins can contribute. So they just don't contribute just because they're beautiful seabirds, but they also contribute on land and for the productivity on land. So if there are some plants that it's important, so it will be more. It will have more nutrients and they will grow more. So it's important also for the plants.
Okay. But what would be the negative aspects of that, though?
The negative?
Of like one on land as well, in terms of conservation.
I think it's just because it's important.
But what would be the negative thing?
The negative?
Yeah.
Yes. Well, if it's too much, it could be negative, the pH. But all the studies that I've seen, it's only good, positive, because it's already established. It's been there for years. So they go in the position. Those plants they needed to thrive.
Okay. Have you ever heard of guano workers? Okay. So yeah, have a look later to Peru, just guano workers in Peru. When you haven't submitted your thesis yet, so you might want to incorporate that.
Thank you. Yes, it's very valid.
Okay. Thank you.
No, has been commented. Yes, one thing that I would like to comment. Well, thank you for the presentation. It was good. data. But I don't understand very well from the outside which is the original parameters. You say they were in the literature different ways,
Yeah.
but they were collected based on extension of the guano on the surface or just getting and collecting guano and making statements. Which was and depending on which is that. So is there an option to know which is the composition of the guano? That would be also relevant in order to see these variations and so on.
Yes, yes, I could also put the composition exactly for Atlantic puffins because it could change
Yeah, this is
between
why.
species. But mainly it's nitrogen and phosphorus, but it could change. But I could also put that in the discussion. But because my model, we didn't work with only the guano. I wanted to estimate the guano. So I didn't put any data that people collecting the guano, and that's why. This could also be another way of doing this study, which is people going inside and collecting it. But in this case, it was mainly the model that I wanted.
So what you make is an estimate of the guano based on a series of parameters in order
Yes.
to obtain that.
Exactly.
Okay. Because when I saw the picture of the cliff with the guano covered and the cover is okay for me. I am microscopist, so this is very easy to see the image and quantify. And okay, we can correlate the extension of the guano on the surface. Depending on how you made estimates of depth, you can have also the volume, the biomass, and so
This
on.
would be amazing work as well, but because of the data available, I would think that Atlantic puffins would have a lot of data, but it's
You
not.
only need a drone to get
Yeah.
pictures.
Yeah, but we need the data from the pictures from before, from the 2000s and before when we had more seabirds. But of course, year by year, then we could also predict the guano this way.
Thank you.
Thank you.
I had one last quick question. So, you have here diet composition. I was just curious because in a science communication story that we have, we talk about the climate change, shifting prey distributions, and the effect that it's potentially having on puffins. And one of the factors is them switching prey.
Yeah.
Did you come across anything about what I know it says 100% fish, but that can really vary, and the nutritional effect of the different fish species can have big impacts on the puffins. Did you come across anything on that and how the guano production will change based on
Yes,
the diet?
there were some articles as well, but I didn't include in the model. But there were some articles that would say that for the chicks they would feed them with different if there was a crisis.
And could the model be, how
It
could the model be
it could
adapted
be
to
modified.
take?
Yes, it would be different. It would be a little bit different values for the alpha one. It would be different here, but yes, it could be modified mainly because of the equations in here. This would change a little bit more.
Okay.
Yeah. But it's hard to find this data exactly.
Yeah.
Which species of fishes they're going up. But it's mainly because I focus on 100% fish,
Yeah.
so it's as if it's any fish.
Yeah, to make it possible to run. Yeah. And you mentioned it was done in R, but I guess it was a specific package or something.
Yes.
What were you using?
No, I just did the equations manually.
Yeah.
Yeah.
Okay. And then for the model, implementing the model.
Yes, as well.
Okay. Okay. Great. Okay. Thank you. Well done.
Thank you.
So we are about 5 minutes ahead of time. Does it matter for you online if we're a little bit early? If there's people watching or waiting for, yeah, you're okay. Yeah. Once you're happy, I'm happy. So that's fine.
In PowerPoint, I guess. Yeah.
And for the there isn't any questions online, I guess.
No.
Yeah,
not
because
yet.
I didn't open it, but
Yeah,
thank you.
I will let you know.
Yeah, thanks. Normally I check, but I wasn't having everything.
No, I have no.
Yeah. And is it Gabriella? Or
Gabriella.
Gabriella.
Sorry.
Yeah, sorry, with my Irish accent.
Yeah, no problem.
Let's see. Okay, so we have our last presenter of this session, Gabriella, going to talk to us next, also on puffins. So we're excited to hear more about them. Over to you, and the best of luck.
Hello everyone, I'm Gabriele Giuseppe, and I'm here about to present my thesis about the feeding movement pattern of Atlantic puffin in a ham soya colony. First, we'll do a big general introduction introduction about the seabirds that are important for marine ecosystem as an indicator, because they're high mobile predators, top predators, that can cover large distances outside of the colony, and are sensitive to prey availability. That is one of the main topic and dangers for these birds because of many environmental and anthropogenic effects, and show in a way that show changes in the lower trophic level. These changes in prey availability can cause variation in the body condition and their ability to provision for the chicks. And we are studying their foraging behavior, so the movement that they do when they search for food for themselves and for the chicks. In particular, we are focusing on two different foraging strategies. The central place foraging, that is possible to see in this graph, in which the birds select a central place, usually the colony, that they use to depart, to collect the food and to consume that back in the colony for themselves and for the chicks. And the levy flights, that's a predictive movement pattern of the birds that consists in smaller steps and smaller movement over high density patches of prey, followed by longer movements to one high density patches to the other before coming back to the colony. The study was realized in the Hemsøya colony in the northern part of Norway. Is a small island of around 1 kilometer in length and is one of Norway's most important breeding colonies for seabirds that comprehend different species, especially auks like the common guillemots, the razorbills, and of course the Atlantic puffin. They breed during summer, usually in July, so they're probably reaching the colony as we speak, and they lay the eggs and act this with movement patterns. The study was realized with the use of GPS tags on different puffins that was giving information in specific time periods, giving information about the time, the time in which the measurement was taken, and the position of the bird in that moment, latitude and longitude. Sadly, we have data for just 3 years. It's a fairly new research that was before focusing only on common guillemots and then expanded on puffins too. And we were not able to collect the data for 2021. So we have the data for 2020, 2022, and 2023. These are the birds we observed. That's the actual movement they realized during 2020 with 7 individuals observed from the 5 to July to the 18. These are the movements for 2022 with 10 individuals observed, and these for 2023 with 11 individuals. Here is important to notice, in particular, this movement in which a bird is doing a particularly long trip further away from the colony. That's probably due to the loss of the chick, so the bird will not have the need to go back to the colony really often to feed the chicks, to provision for them. First, we observed the variation between the years, and we observed that probably, as we will see later, the 2020 was not optimal year for the puffins. They had longer foraging trips overall, followed by 2023 and 2022. As I mentioned before, there's the pretty evident outlier of the long trip with great distance. So taking that into account and removing that outlier, we will see how actually the trips in 2023 were shorter than in 2022, showing an improvement in the environment. We observed if the time in which the birds were leaving the colony were increasing or decreasing going on with to the end of the breeding season. The hypothesis is that going to the end of the breeding season with the hatching of the eggs and the growth of the chicks, the birds will require more frequent trips to back to the colony, so shorter trips overall, to feed the chicks, so that had an increased need. Nevertheless, we observed this pattern only in 2023, while in 2022 we observe a longer trip going on with the breeding season. We then observe the speed of the trips. These are just the observation of the feeding trips, so the measurement were taken only when they were outside of the colony, and we usually see peaks in the end and in the beginning of the trip, of course, because the birds are leaving and reaching the colony with high speed. More interesting are the peaks in the middle of the feeding stops that are showing the levy flight. so the fast movement from a high density patch to another. While the lower speed measurements were showing the period of times in which the birds were technically drifting on the water and actively feeding. Similarly, it's possible to observe that from the QGIS maps, where consecutive measurements where when they were farther away from each other, were showing a high speed, and closer ones, as in the one circled, were showing the drifting on the water. We observed the stop variation, so the feeding stops, so the moments in which the birds were actively feeding, so drifting on the water, and we observed a pattern that was similar to the one of the feeding duration. So longer feeding stops were significantly longer in 2020 than compared to 2022 and 2023, similarly to the overall feeding duration. That's probably due to the lack of prey availability that were requiring both longer foraging trips and stops. We observed this correlation, so if there was correlation between the duration of the feeding stops and the distance and the time outside of colony, we observed actually positive correlation for both the measurements, but the significance is really low. Probably more research will be needed, and it's still a debate and further research. We observed the refractory time. We considered this the refractory time as the time in which the birds were staying in the colony after our foraging trips. The initial hypothesis, contrary to what is possible to believe usually, is that from a long foraging trips, there were considerably shorter foraging stops because a long foraging trips means a low prey availability, so more difficulty for the bird to collect enough food, and so they would probably require shorter time in the colony before leaving to provision properly to the chicks. Nevertheless, we observe a positive correlation, so that's probably the need of the birds to care for the birds in the colony, for the chicks, or rest. We then observed the site preference of the birds. We considered three main areas. So the colony is here, so they were like the deep waters that were further north from the colony, around here, and they were like from 200 to 450 meters in depth. The waters around the colony, the one immediately in the perimeter, that were also used for other functions like socializing for the birds, and the shallow water, usually in the west, closer to the mainland Norway, and with 50 to 200 meters in depth. We observed the use of the areas. These are the different observations in the different years, and we can see a really different pattern from year to the other, showing variances in the prey availability in the different years observed. In fact, in 2020, the birds were mostly visiting deep waters, while these tendencies switched in the following year for around the colony mostly in 2022 and shallow water mostly in 2023. Overall, the around the colony waters were the most visited, with shallow water and deep water with an equal amount. We observed there was a correlation between the different site used and the duration of the trips, and as we were expecting for our hypothesis, the birds that were going to the deep water were doing that only if it was really necessary because of lack of prey availability, and so longer trips were required, while shorter trips were not significantly different in length between shallow water and colony. But this is the same. We observed site fidelity, showing the period of time in which the birds were consistently in consequent measurements returning to the same spots, the same area, main area, to feed. So not only for the movement, but actually feeding on the feeding in the water. And we observed a good amount of site fidelity. Around 66.6% of the birds observed were showing high, medium high to high site fidelity, showing that the research and the memorization of the important beach area were really important for the birds. We lastly observed the breeding success of the birds. We had data from 2019 to 2023, and with around 120 nests observed for each year. And we observed a great variation from 2019 to 2020. They were showing a really low breeding success, with an increasing in 2021 and a peak in 2022, with almost 50% of the chicks surviving after, like it's not really explained, after 20 days the the chicks were still alive and healthy. So like good breeding success with a small reduction in breeding success in 2023, but still a good health. We observed the correlation between the breeding success and the foraging behavior, in particular the duration of the trip and the distance from them. And we observed how significantly there was a negative correlation between the breeding success and longer trips further away from the colony. Similarly, from the area used, we observed a positive correlation between the breeding success and the birds that were feeding in the areas around the colony and in the shallow water, while a negative correlation for the deep water further north. Nevertheless, it's important to consider that these last observations are not statistically significant, probably due to the small size of the dataset that still will require many years to complete. That was all. Thank you for your attention.
Brilliant, Gabrielle. Thank you. So, questions from the audience first? Yeah, Daniel.
Could you go back to the slide of the distances?
Which
It's not that the question is related to that. No, the like the one at the beginning of the average maximum of the distances. This one, okay, thank you. I have two questions.
Sure.
Simple one. You know the frequency at which the tags would take the location?
Sorry, can you repeat?
The frequency, the frequency at which the GPS tags would take the coordinates.
Yeah, were giving information every 5 minutes.
Okay.
But the GPS, as I said, is a fairly new research, so they were not optimal. And when the birds are underwater, we were not receiving a signal. So it's more
To me, it's
complicated
the same.
when the
And second, how many trips would these puffins do in one day?
actually was really variable,
Okay.
especially in 2020. That we say probably were not optimal conditions for food presence for the place. So there were also birds that were staying out for 25 hours, while in 2022, where the conditions were better, they were having really fast trips in some periods. So it was really variable and was
Thanks.
When you say deep water, how deep can a puffin go? Or do you know?
about 60 meters.
Impressive.
What was the deployment period of the tags?
Sorry?
When were the tags deployed? GPS.
Oh, in the beginning of the breeding season was variable in the years here, like from 5th of July to 9th of July, depending on the researchers. I could not do field work.
So, any other audience questions? We'll move to the jury. Okay, so to the jury.
Can I go ahead first?
Okay, take the right questions.
I don't make so many questions. Okay, thank you for the presentation. Again, I not recognize it's not my field, so my questions can be maybe complicated because they are from the ignorance. I was surprised because you were trying to compare between different water depths in one of the cases, and when you look at the results, it was 30, 40, 30%, and you were commenting that there was a trend to be in the middle one. I don't remember, it was the 41. I don't think this is statistically significant. It is not proof as such. So my perspective from the outset is that there were not any differences. So my question is, why should be depth of the water be relevant for each behavior of this? Even provided that I guess the shallow waters will be at least 50 meters or something like that. So it's within the range of diving of the bird. So why water depth?
Actually, that's correlated to analysis that I could not put in the presentation. We also observed characteristic of potential temperature and chlorophyll concentration that were like secondarily impacting the seabirds because they were impacting the presence of rays and larvae, the drifting of the larvae. Because in Norway, we can observe the drifting of the larvae of the fishes further north, and when they reach base, and there was a variation so significant because of the smaller data set and complication. But the initial idea was correlated with the environmental variables.
But the environmental variable, the abundance or the easy to get the praise, do you expect that there will be a difference between the abundance of the praise, of how much difficult or easy is to get the praise for the birds, depending on the water depth, or it's not related to that at all?
Yeah, I don't really know. I would expect, based on the praise, they mostly praise on herrings there, so we can observe the depth in which they swim, but yeah, I don't have data on that or results.
Okay, thank you. That's from my part. Thank you very much.
Hi, Gabrielle, thanks very much for your presentation. It was really well done. As usual, have questions. Okay, so first of all, I just want you to clarify, when does the breeding season start for puffins? Because the way they said it sounded very late for us, which, you know, I mean, I know you were a bit further, but when does it start? When do they start coming to the colonies?
Yeah, there is probably the end of June. Like our data was only on July.
Okay.
Collecting, but on that colony they will reach like half of June to forward.
That's when they come in for courtship?
Probably yes.
Probably, or yes?
Yeah, I don't have exact data. But
Okay, yeah, because for us in Ireland, they start coming to the colony between March and April.
Oh.
And each year earlier because of the warming, and then July, like, chicks are leaving. So that's why I was a bit confused with timing, but again, I'm not in Norway, so I don't know. But yeah, like July is like chicks are leaving, so if that would be similar, you know, this GPS data is very late to look at feeding, so maybe check on that.
Yeah.
Okay, so you were saying that at the end of, you looked at some of the trips, and you were saying that was it that some of the trips were very long, and you thought it had to do with the end of the season, that maybe
we observe a correlation, and we observe like longer trips in the end of the breeding season, contrary to our hypothesis, because we were expecting shorter trips, because of course if the chicks are bigger, like more older, they will require more food, but we found
But it should be the opposite. So in the very beginning, the chicks need to be fed every 2 hours. Like basically they're like, it's like a newborn baby, you know, they are like all the time wanting food, because they need to grow really fast. But at the end of the season, they are bigger, so they don't need to be fed that quickly.
Found the answer.
Yeah, so you probably have to look into that if you were publishing and you know. Okay, so can you let me know how far from the colony was each trip, more or less, the average again?
The average we have.
Yeah. So is that like every trip?
Yeah, all from
for
all
each feeding trip?
Yeah, each trip, each tag, so for the year, so that was the average. The only data is this one that's wrong because of the outlier with the longer one.
So they would go for one trip.
Or like the longest
is that the round trip, or is that where they get there?
Oh, is the most distant point.
The most distant point they go. Okay. That's interesting. So, so we know that puffins are inshore feeders. Okay, so they would be feeding closer to the colony. Okay, so you saw that you had like an outlier that went really far away. And what do you think that could be? Yeah, why would they not go, you know, like the others, closer? Any ideas?
Yeah, not really.
Because you mentioned something there.
Yeah, I said that probably they lost their chicks, so they didn't require to go back frequently to the colony. But
so they could go further because nobody was waiting for them.
Is atypical even in that situation, but it's the most probable. Sadly, we don't have the data based on the specific bird if they had breeding
So
success.
the birds are tagged, but when you push your GPS on the birds, do you not get the tags of the birds that should give you the age of the bird and lots of?
Yeah, we don't have information of the age.
But are these birds tagged?
Sorry.
Are they ringed? Have they been tagged?
Yeah, they've been tagged.
When they were chicks, are these colonies monitored since they were chicks?
Oh, if you mean the parents, if they are monitored?
Yeah.
I don't think so. It's
well, like all of the colonies normally, are they managed, or the colonies that you're talking about, are they managed?
There are some research, but we're like only at least for my research group, that's Nina, the same that we work with, is starting with puffins. I have data for, since 2018 for common lemons, and then they started with.
But GPS data. But what about productivity data and anything
we
like
don't
that?
have.
Nothing.
At least I didn't have them.
Oh, that's unusual that they want to put GPS on random, completely not known birds. Okay, because normally, you know, we would tag the individuals so we have their, you know,
Maybe
we
I
have
just
all of
didn't
that
have access to
information.
the data.
Okay, yeah, because it's good to correlate with the age and you know, we might know more about the individual.
Also
And that
we
might
have information
explain-
of the sex of the birds that I asked, but we didn't have.
Well, but the sex of the bird is very unlikely that you have that. But the age of the bird, so when the bird was tagged, normally it's when they are chicks, like around 6 days of age, they should be tagged. So you should be able to get that kind of information. No.
Personally, maybe my research lab have it, but they never gave it to me.
Okay. Okay. Yeah, no, I was asking if you had any explanation about that, because you said, you know, there's a possibility that they don't have a chick to come back to, and then there's that. But like going further doesn't always mean that is a bad thing, because offshore birds would go further to look for more nutritious food. So that could be a positive thing and not a bad thing. So it could be that they are more experienced, perhaps. So that's something, you know, that you wouldn't discard as like, you know, that. Obviously, also if they don't have a chick, they probably wouldn't be staying in the colony for nothing. Okay. Okay. So in terms of that, are there any diet studies on these colonies? I mean, if you probably don't know if they have diet studies for this colony.
No, we know what they feed, but we don't have any information of if they're bringing specific prey back to the colonies. So we know in the area, in the colonies around Norway, where they're mostly herrings and sandpits.
Okay, and how would you know from their trips that their stops that they are getting fish or not getting fish? You would know. Okay, because you can probably get some of that from the literature as well, in terms of the amount of time that they're spending on each. Yeah, yeah, and because if you think about it, do they have to feed themselves as well? You know, so they are not just going there for the chicks. So the multiple stops doesn't necessarily mean that they or even that they can't find something and they have to keep going. It might just mean that they're feeding themselves, which normally was what they do first, and then bring something for the chick. So they always prioritize themselves. Yeah. Okay. No, I just want to know that if you understand those things. Okay. Yeah, I'll just stop there. Thanks very much.
I have just one last question of what do you think was happening in 2020? Why?
We don't know, probably changing in the environmental variables, so they had lack of. We just know that probably they had lacking density of rays, but the reasons can. Puffins are particularly susceptible to disturbance.
Is there any data that you can, like, is there anything collected on fish in that year or on environmental variables in that year?
Not that I specifically know.
Okay, okay. Sure. Nice work, well done. Yeah. So great, well done to our three speakers in this session. And now we have a break from, well, 10:30, we're a bit early, so a bit of a longer break, which is nice for everyone, I'm sure. 10:30 to 11, so the next session starts at 11, and there's coffee break, I guess, downstairs. You'll smell it hopefully. So well done again to the we're just going to start the streaming, but as you can see, there's microphones everywhere, so it's the same in all the rooms as far as I know. Try to keep shuffling, mumbling noise to an absolute minimum because that's all going to come out quite well online, so it makes the presentation much more difficult for the online audience. So in this session again, we have 3 speakers talking about super interesting topics. We're going to have 15 minutes for each presentation and then time for some audience questions. We can see how many we can fit in, and then jury member questions. So I'll ask the audience first, so if you do have questions, do be ready, please. For the speakers, I'll give you kind of a 2-minute signal. If you're not looking at me, I'll try to give a very obvious 2-minute signal, and you know you have 2 minutes left. And then if it's 15 minutes, I'll stand up and you really need to finish within seconds at that point. Yeah. And so without further ado, I hand over to Katerina, who's going to talk to us about loggerhead sea turtles, and I'll let you tell us more about that. So the best of luck with your presentation.
Okay, thank you for the word. I'm pleased to see you all and welcome. And today I'm happy to go back to the Azores with you for a little bit. And we are going to explore surfacing behavior of the oceanic stage juvenile loggerhead sea turtles together. So we know that 7 species of sea turtles are around the world, and 5 of the species are occurred in the Azores. It's a Kemps-Ridley, loggerhead sea turtle, leatherback sea turtle, green and horsebill. But I would like to point that the most prevalent and common species in the Azores is a loggerhead one. So loggerhead sea turtles are classified as a vulnerable species, and it's also because their past they were hunting for eggs and meat, and supposedly it's still happening, but they are still vulnerable because of some skin diseases or of course bites from predators. But a significant threat in Atlantic Ocean is the, of course, anthropogenic activities such as entanglements to the long gears, or for example bycatches, and also some collisions and strike with the boats. I didn't put a picture because you don't want to see that. So turtles are characterized by a slow growth, long activity. They are solitary species, and also they are highly migratory species with a complex lifestyle. And since the small turtle, really small, 5 centimeters carapax, they are going and trying to enter to the open water, open ocean, and they are actually trying to explore the ocean. And then they are passing the Neritic Ocean, Neritic zone, and then they are becoming an oceanic juveniles, or as repeated as a lost year. So why oceanic stage juvenile? Why we focus? Because we don't know much about the time that actually after the hatching, what are they doing there? And we don't know much about the surface behavior, so it's still poorly understood. So surfacing behavior. We know that 90% of time of like their life, they are underwater, but they were referred as a surfacers instead divers. So the question is, what is behind this claim? And again, why are they surfacing? And we know that also they are ectothermic organisms, so they are maintaining their body temperature because of their surroundings, and also through the basking, but also they need to go up they need to breathe, they need to rest, they need to eat, they need to recover from anaerobic activity, or probably they can just chill. And how we can address these ecological patterns? We can do it through the monitoring, because it's just the most common use method to also track the local aggregation to determine their abundance, range, and distribution. And we can do it through the visual sighting surveys that are often employed. And also with these visual sightings, we have some challenging arise in the estimation of abundance of sea turtles. The most, we also look into it more because the visual sighting, it's more like we are on the boat, we have the observers, and then we can just see the turtles. So then we know that there are some biases, and the relatively, or we consider the availability bias as a concept for a distant sampling that just a proportion of sea turtles can be seen. So we can just, the turtles are present, but we can just miss them. So the estimation of this bias is complex, but it's crucial for improving actually sea turtles monitoring. So our aim was quantify the relationship between surface behavior and environmental conditions. So the surface behavior is not also influenced by like the thermoregulation and stuff like that, but also the external conditions that they actually create as a whole. And also our hypothesis was that the time that loggerheads spend at the surface is influenced by these conditions. So temporal conditions as the time of the day, daytime segments and season, and certain environmental conditions such as sea surface temperature, cloud cover, blowforce, and moon phase. And study area is the most amazing. I performed this study in Azores archipelago, and still I'm really surprised some people don't know where the Azores are. So they are in the middle of nowhere in Atlantic Ocean here. And specifically, I was in Horta, here in a small island in a Fayal. And it's a really remote area. It's renowned for its unique weather patterns and distinctive volcanic submarine topography, which is really important. Also with great marine biodiversity, and I just put really nice pictures. And also it's a really important foraging ground for various marine vertebrates. So for data collection, we tagged 18 juvenile sea turtles, and they were equipped with high-resolution daily dairy tags around Azores archipelago from autumn 2020. And these devices can also include a lot of parameters, with some of them has also GPS. And here we can see the map where the turtles were tagged by the season. So mainly close to Fayal and Pico Island. So also I would like to point out and emphasize that approaching and capturing sea turtles is quite hard. And sometimes it's really hard and it's challenging. So this is my supervisor, and he is trying to see the sea turtles, and for the catching we use a dip nets. After we caught the turtle, we started to do the external inspection and samplings, which was actually really important. And we looked to the turtle. The turtle is, we do the external. So if there is some lesions, if she behaved differently, or actually what is happening. And we did the basic samplings, such as curved carbax length, curved carbax width. We also took samplings from neck, shell. Sometimes we also took some barnacles for the further analysis. The tagging itself took us for approximately 45 minutes using instant epoxy or suction cups, as we can see here. And then we release the wild sea turtle. And the tags were released after 24, 48 hours, in our case 24, using the GTRS galvanic time releasers. So here you can see the approaching the turtle. This wasn't the best, actually, because we didn't got the turtle. But here is a time lapse of how each step of deployment the tag. Sometimes it took us longer, sometimes took less. It depends of everything, the weather as well. And here we can see the diving, the releasing the turtle. First time what the turtle should do, take a breath and then deep dive. But sometimes science doesn't work accordingly to the plan. Sometimes they're just chilling there. And this was really nice because the turtle just spent there almost 2 days. So they were check her and she was there, but she died after, so it was okay. For the data, we need to retrieve the tag. So we did it from land, and then if we did it from land, and it was really, really important for us. We need to get to the elevation to see if the tag is at the surface or not. And if we knew that it's on the surface, we could go to the boat. So this was the first part of the data collection. The second one was also took temporal variables and environmental variables. We took them either from text, but also from other sources. So as I said before, we use season, daytime segments, time of the day, and for environmental cloud cover, both for sea surface, temperature, and moon phase. Data analysis were performed in R. Everything also exploration was carried out following the methodology from previous literature. And the first thing that we had to do was, the question was, okay, so we have to consider what is surface for us. So we consider 0 to 1, so 0 means no time at the surface, and 1 all the time at the surface. And then the data was recorded at a frequency 10 Hertz, which is really small, and it allows to see the precise of the data, but also it results like as a large volume of data. So because we wanted to correlate and link with the environmental variables, we have to reduce the variability. So we decided to stratify the hourly. So then we had, okay, the time at the surface, the sea turtle spent at the surface each hour. We also assess the collinearity, correlation between two covariates, because again, temporal variables and environmental variables are linked together, and it's really hard to just talk about season and don't include the temperature. And so we assess and we construct also general line models. We try to start with GAMS, but it was really hard because of the nature of our data. So for the result and also discussion, we found that sea turtles spent much more time at the surface during the early morning, 6, 7, and then during the day, except the time between 10 and 14, because we had really low sample size, so we cannot actually draw any conclusions. But they spent less time during the dusk and night, which could be during the day they are basking, they are just actually foraging, and during the night and dusk they can just resting. And it's actually really nicely correlated with daytime segments, that we can see that during dawn and day they spend much more time at the surface, during dusk and night they spend less. Sea surface temperature and season is also correlated together, because of course we can see that they spend much more time at the surface during the spring, autumn, and we can also see similar trend for summer, and we can see also drop of time at the surface during winter, which also can be correlated with during winter there is no food, there is cold, there is also clouds, so there is no point for turtles to go up, so they are staying there. Also the metabolic rate is super low, so they are just resting there. And during the spring, summer, and autumn, we know that spring is like the first sun. They're going up, heating up, and they have a lot of food. They are so happy, so they are just staying there, and they also, yeah, they're chilling there. During summer, the water is high enough to just not be up in the surface. We also know that during summer there's more oligotrophic waters, so they are not spending as much as time at the surface. And during autumn, actually there is a second round of spring, we can say, because there is secondary bloom, so they are also spending much time. Maybe for us, interestingly, more time than we expected, but it's also linked with the sea surface temperature, so we can see that they spend more time between 18 and 22 degrees. Cloud cover, they spent more time at the surface when the scale was zeros. 0 means no cloud cover, 1 cloud cover. And this was interestingly for us because we looked also into for the summer, and we saw that probably the temperature was so high that they just decided not to spend much more time when they were like under the sun, but they just went to the survey when there was a cloud cover. Beaufort scale reveals the clear trend. So scale 0 means that there is no wind. 4, it's really rough sea for us. So again, we can see that they spent much more time at the surface when the wind was actually calm, and they didn't go to the surface when the wind was kind of rough. And this was for summer as well, so we can see the drop off from the scale 2. Moon phase was really interesting one. So we can see that they're surfacing during the full moon, more from 0 to 5. And it could be linked with the vertical migration of the prey. So they're more interesting. There's also a lot of light. They're going to foraging during the night, but also it could be because they are trying to hide against the predators. So the predators are going further up. They are also trying to eat, and they are just actually resting on the surface, so they cannot see them. So what we found 48% of the variability of our data. 3 independent variables were included in the model. And also, as I said before, what we found that they spent much more time at the surface during the dawn and day, more than night and dusk. And also we found individual effects, and we also know that they spent more time at the surface during the spring and summer and autumn, and less in the winter. So it's just a discussion that we already went through. And I would like to just say that we confirm our hypothesis. So we know that the loggerhead sea turtles spent at the surface, and they were influenced by temporal conditions and data and environmental conditions. And for future research, I think would be nice to have more meticulous data collection, effective tagging methods, and then also high resolution sensors and health assessment to get more reliability and accuracy of the data, and also advance our understanding of sea turtle ecology. I think it's really important also for conservation efforts to developing cooperation with more groups that are related to sea turtles, and with the research group to develop some MPAs and try to reduce the long-line fisheries and really the impact that it's on the sea turtles. And I would like to thank you all, the institution and people that I could perform and conducted my my master thesis, and thank you for this presentation.
Attention. Yeah. Thanks very much, Katerina. Well done. Who made the turtle? My first question.
My friend, I
Nice.
got a turtle 2 days before I left because
Excellent.
she
Nice.
is doing 3 turtles and
Yeah. Okay, so to our audience members, first, if you have any questions for Katerina. Yeah, Daniel.
It actually the point where really nice they took acceleration and gyroscope and all this. Did you use all this data for your study, or some of this data will be used?
some of the data will be used for different. Yeah, it's really hard. Some of them I used the CAT one. We also have the data from wild computers, but we didn't include them because we didn't have a lot of data. So we use just the high resolution, because with these you can just go more to the diving behavior, and they are much more fine scale. So the rest will be used after. And still, it's since autumn 2020, so still the project is going. Right now, but we couldn't go to the sea. My field work, I went just twice. So it was really fast workshop of tagging the turtle and
Yeah, another question.
Yeah, first of all, thank you so much for this very clear and nice presentation. And did you in the end were able to determine one parameter, like environmental parameter, that was the most significant?
yeah, there were 3 actually. I'm sorry, maybe it wasn't so clear because I have to speed up. but in the end we put 3, and they were daytime segment season, and ID. So we try to the model itself. We try to look into it to different behaviors. So it was more like explanatory analysis to see fail or no. This environmental variable is really nice. But the most actually, so we could see differences, was daytime segment season and ID.
Any other audience questions? Yeah, one more over there.
It's the result that surprised you the most that we didn't expect when going into that.
That's a good question. Actually, I think it's pretty logical, I would say. But I like the moon phase. I really like the moon phase when actually I think the turtles and predators play like the game be seen or not being seen, because they are just standing at the surface sometimes and the predators are down and there is the food that is going on and they are just foraging, and then really it's hard to say, but I think that was for me the most. Yeah, I didn't know about this before. Actually, I didn't know about a lot of things before, so everything was actually surprising. No, this was the most, I think. And of course, after the sea, that's a good point. The sea surface temperature, no, the cloud cover, actually, when the line went down and they up, because it's also the question, okay, what is the optimal range of the turtle, or what is actually, what is optional temperature for the turtle? How much they can handle? It's also like maybe 18 to 25 degrees. Could be, and then maybe it's too much for them, so they're dive, or maybe they can wait for not really nice sunny day and they can go more up. It's also like, I don't know, they are really complex.
At least we start to find out a lot more about them from this. So to the jury members then, who wants to start? Karim? Yeah. Okay.
Okay. Also, thank you for the presentation. In your pictures, I mean, your thesis is about the juvenile stage, but in the pictures you showed, you had very small ones and some that didn't look to me like juveniles. And one of your variables that was important was the ID, which is the individual. So could it be that size is you didn't look at differences in size as a potential?
No, that's a good question, and I didn't point out that I could have. It was in the slide with the monitoring, I think, and availability bias, because it was also different tags. I wanted to show the different, like, how they look like in the water with the tags. But yeah, the ID, yeah, also it's hard because the turtles are slow growth. So the size, they can be like, they can be small, but also they can be bigger. So that's why the effect is it's different.
What was the size range of your whole sample? I mean, some of them were very small and some of them were like this. I mean,
yeah,
was it really
more,
that wide a range of sizes?
Yeah, could be. But the size, I have to admit, I don't remember. Actually, the range was until 40, 50.
Oh, that's quite a big size range. That could. Yeah. And when they dive, how long can they stay underwater? What's the maximum time?
The longest one, the tagging was 19, like in the water for one brief, or
yeah,
or how we tag.
When they go down, how long can they stay underwater for?
20, 25 minutes.
Okay.
Also, of course, depends if we are talking during the summer or during winter. Because during summer, if the temperature is high, they're moving a lot. They are expending the energy, so they also have to go more frequently up to breathe. And the metabolism is more higher and faster than during winter.
Thank you.
Okay, thanks. Thank you for your presentation. So, in the context of your study, and to join this question, the first question, so what are you calling juvenile?
From the time that they, after leaving the neritic range, around, until like 25 years old, probably, from the
Juvenile. Okay.
yeah, like they are like in the Azores, they are staying up to like 12 more 15 years, and they are actually, after they're reaching the maturation, then they are actually.
Then you know when this specific species is sexually mature.
Males and females 36 to 42 years old.
Okay, so you still call them up to 18 years old, I mean juvenile and not subagliator. Okay, fine, thank you. So can you tell me your main working hypothesis?
So we hypothesized that the time that loggerhead sea turtles finally surfaced was influenced by the temporal and environmental conditions.
Then this behavior, surface behavior, okay, maybe I'm wrong, but these animals are breathing, so it's a default state. I mean, they need to go at the surface to breathe.
Okay. Yes.
So it's a kind of default state. They need to go. There is a need physiologically.
Yeah, of course.
So why did you address this question rather than not the contrary? Meaning why they need to go deep and how long they stay?
Because my colleague focused on diving, so that was my colleague did this thing, and I more focused on the surfacing.
Okay.
So this question was my question, and her question was like more diving.
Okay.
So that was, we were interested how they are influenced, and also, yeah. So we can address, actually we can see, okay, we can go to the ocean, we can try to look for them, maybe it will be much more easier for us when we know this information than just go during the winter. We went during the winter, and it was really not the successful, but we knew probably before. But yeah, right now we know, okay, we are not going during winter a lot. We are gonna focus on spring much more.
Hi, Katerina, thanks for your presentation. It was lovely. I just want to understand a little bit. So you, how long did you leave your tags for?
24 hours.
So 24 hours, and how many turtles?
18.
18, okay. And how did you do your, you did that throughout the year, a whole year? Because you got all the seasons there?
Yeah, all season, yeah. It's, so my turtles, my colleagues' turtles, they were, actually, yeah, we say it like 24 hours, but they weren't tagged for all 24 hours. Sometimes they were tagged for 19 or 13 or 4 hours. So we also excluded 2 turtles from the model. So in overall we had just 16 turtles.
Okay, why did they stay on for that little?
That's the thing, because maybe the tags, as I said, are highly, there's a final scale. So maybe it could be because of the the tag could be, I don't know, it was a stress, or the attachment could be also not well done, like deployment. So that could be a lot of reasons why not. We don't know that. So we had to exclude it. We didn't have a data for that.
Okay, but I suppose these tags are normally used for that anyway, and there's studies about using them.
Yeah.
So you wouldn't know what are the limitations of the.
Yeah, it could be battery. It could be of course the pressure. Like could be a lot of things.
And are there studies on the stress levels, because you're 45 minutes with the turtle on the boat under the sun?
Yeah, that's what I didn't say. Approximately 45 minutes to not stress the turtle, we try to be as fast as possible, including a lot of people was seasick all the time. So we really try to put everything together.
Okay, and on the studies, the literature, like, does that show any amount of time that
No.
you shouldn't?
Actually, no.
Nothing.
No.
Nothing.
I think, but I didn't find any.
Okay, because there's lots of studies on, like, the amount of time that you can spend and also the weight of your tags in terms of how it's going to affect. So you're showing that turtle that didn't actually go diving straight away, which is normally what they would do to escape. So, yeah.
Yeah, that was the video with the turtle, the backpacker, and she
She just stayed on.
Yeah,
Okay,
she just stayed at the surface.
Okay, can I just have one last question to wrap up? 1 second. What's the importance of your study in terms of the conservation of turtles? So what's the meaning of this all, finding out how long they stay in the surface for? What's the importance of that?
In Atlantic Ocean, around Azores, there's a really big problem with long-line fisheries because of the tuna, because of the fisheries and overfishing. So there's a lot of cases that there is a collision or we receiving turtles without flippers or sometimes without heads, which is really, really bad. But of course, so yeah, the meaning also would be in the future to develop some MPAs, for example, to know where the turtles are mainly, and to just try to actually also cooperate with the fishermen. That also the biggest, and what are we trying right now to talk more with them and just show them, okay, the turtles are here, please try to avoid some, also like maybe places, but it's hard to say. Like for the future, we are trying to cooperate with them as well. So if they see the sea turtles, they are contact us so we can actually a little bit have an idea where the turtles are and where are they staying. Also, it's hard to say again because it's a rich terrain under the water and a lot of steam amounts also. Yeah, so the most important is to monitor the turtles, maybe with the 3D cameras also to see where they are going, why, and yeah, this could be really nice for the future, I think.
Thanks very much.
Okay, well done again.
Yes.
Okay, so now we stick with loggerhead turtles, but we move to Italy, and Janina is going to present your work. For this, you can use the arrows like this injustice. Okay, so over to Janina and best look at your presentation. Thank you.
Oh, yeah, no problem.
Yeah. Okay. Good morning, everybody. Welcome to my thesis presentation titled Extragos: Environmental Factors Affecting Hatching Success of Loggerhead Turtles from New Emerging Nesting Sites on the Western Coast of Italy. My name is Janina Mires and I come from Peru. My presentation will follow the structure of a research paper. So I will start with an introduction to give you a general idea of my topic, and I will conclude with the conservation implications and conclusions. To start, it's important to know that the regional management unit of loggerhead turtle in the Mediterranean has the major nesting sites in the eastern area of the basin. But in the last 10 years, we observed a migration to the western area of the basin, with some beaches in Italy in the Campania region becoming frequent nesting sites. However, we are talking about a conservation-dependent unit. This means that the long-term conservation measures and assessment strategies should also incorporate these new emerging nesting sites in order to remain effective. This migration could be related to high temperatures creating suitable nesting areas, but also to a spillover effect thanks to the successful initiatives in the Eastern Mediterranean. But the problem is that we don't know a lot about the long-term viability of these areas, because the turtles are going to face threats and also areas that are not prepared with the conservation plans and the current and future climatic conditions. I'm referring to rising sea levels, extreme temperatures, and the change in the frequency or the intensity of the storms. All this can take the species into an ecological trap and stop this expansion. Turtles are really vulnerable to climate change because environmental factors are intimately related to the reproduction. In this sense, factors such as the humidity, the salinity, the levels of exchange of gases, and the temperature of the sun will determine the phenotype and the fitness of the hatchlings, but also the survival of the embryos in terms of hatching and emerging success. Previous studies have demonstrated that these environmental factors are going to affect in a different way to the survival of the embryos depending on which environmental factor we are referring to and its characteristics. For example, tidal washovers, high temperatures, rainfall events, and their frequency, intensity, and duration. But the moment in which these environmental factors occur or change, it's also important because it's been demonstrated that early and late embryonic stages are critical for sea turtles' development. In this sense, my aim was to determine how environmental factors, such as the temperature, tidal washovers, and rainfall, are affecting the hatching success in loggerhead turtles during the 2023 nesting season in the Campania region in Italy. As I mentioned, I developed this study in Campania, in the southwestern coast of Italy, and I divided my study area in 4 zones. Here we have the Domitian littoral coast, the Gulf of Naples, the Gulf of Salerno, and the Cilento coast. But the data analysis was focused on the Domitian and the littoral coast. The fieldwork activities were divided into 2 phases. The first one was the nesting activity monitoring conducted between June to August, and it consisted mainly in daily food patrols, searching for these female crows here to find the nest or for the nesting females. The nests were relocated in case that they were under inundation risk. The second phase was the hatchling emergence monitoring that was conducted between August and September, and we have 2 monitoring types. We have first the continuous one, because we have 24-hour surveillance cams next to the nest, and the non-continuous one with regular checks of the hatchling tracks going to the sea, as we can see in this image. The reproductive parameters that we took into account were the incubation period, the clutch size, the hatching success, and the emerging success, being the most important one, the hatching success. We also record the environmental factors such as incubation temperature, and we use data loggers. And for the tidal washover and rainfall events, we gather this information with volunteers using Google Forms, and all this data was standardized and classified, and we divide the tidal washovers into tidal flooding, severe, light, and potential washover, and the rainfall into a strong, medium, and weak. All the eggs that did not hatch were collected to identify the embryonic development stage according to Miller 2017, and we also estimated when they die and how, considering the development time also proposed by these authors. For example, here, we have a clutch that had an incubation period of 60 days. Based on the development time per stage, let's say that they died between the stage 25 and 26, we could be able to determine that they die after 30 days that the clutch was laid, and during those periods, tidal washover or a rainfall event occurred, we determined that this was the death cause. The data analysis was divided into 3 phases: the reproductive parameters, where I did descriptive statistics mainly, and then to determine how the environmental factors affect the hatching success, I developed a generalized linear model using the predictive variables of tidal washover, rainfall events, location, and relocation status. And to identify if there is a difference into the mortality across the embryonic development stage based on environmental factors, I took all the embryos that I identified and I put them into 4 groups. We have the early stage, 2 groups of midterm stages, and late stage. And the mortality was calculated per clutch considering the unhatched eggs. Based on this, we recorded 54 nests in Campania region in 2023, and 35% were in the Domitian littoral coast and 50% in the Cilento. The mean hatching success was around 60%, and we found significant differences between the clutch size and the incubation period between these 2 areas, with larger clutch sizes in the Cilento coast. Here I have the results of the model, and this is a bit complicated. I wanted to determine how the environmental factors affect the hatching success, so I will explain step by step. Here in the axis F, we have the tidal fluviums and severe washover in terms of number of events. So we have from 0 to 5, and in the axis Y, we have the hatching success in percentage. Also, we have the median rainfall events represented by these different colors of blue. And each column represents a location. Here we have the Domitian littoral coast, and here the Chilento. And each row represented the relocation status, the non-relocated nest and the relocated nest. In all the cases, we saw that the higher the number of tidal fluviums and severe washover, the lower the hatching success. But these environmental factors affected in different way to the nest, considering the locations. For example, here, after 2 events, we observed that the nest almost completely failed. And in the case of the Chilento coast, they survived between 2 and 4. The incubation temperature was kind of stable because it was between 25 and less than 34, but we had some abrupt changes because of tidal washovers, as we can see here. And we also explored if there is a difference between the mortality across groups, as I mentioned. So we identified actually a significant high mortality in between the early and later stages. And also we identified like kind of a pattern when they were both events were present, like rainfall and tidal washover, the mortality was high. And each color of these boxes represent the condition under the embryo's life. For example, here is when there is no rainfall event and no tidal washover. The second one and the third one is when one of them is present and the last one when both are present. Well, considering all this, we can say that in 2023 in Campania was the third region in Italy with the highest number of nests after Sicily and Calabria in the south. And the reproductive parameters that we presented are different from other studies in the previous year, even in the same study area, with lower hatching success for us, which could be related to the environmental factors occurrence, because in 2021, only 1 nest was recorded as inundated. However, the reproductive parameters can be associated to the female fitness, which at the same time is related to the food availability and the foraging grounds quality. Actually, there is evidence that in the Eastern Mediterranean, there are females that are laying larger clutches size when they eat in high productivity areas. Considering this, I propose the hypothesis that there are 2 different groups of females nesting in the Campania region, and the females that eat in a productivity foraging area are going to the Chilento coast to nest. We observed that there was a negative effect of these environmental factors in this study for the hatching success, and this could be associated to the moisture, salinity, temperature synergism. This means that, for example, when we have a tidal washover or a rainfall event, there is an increase in the water saturation. Then there is a limitation in the gas exchange, and the embryos die for asphyxia. When there is a tidal washover, also the salinity increases, so the eggs lose water because of osmosis, and they die for desiccation. Also, the water intrusion can decrease the temperature and decrease also the hatching success. But these environmental factors affected in different ways considering the characteristics, as I mentioned in the introduction. In this case, we observed that the greater impact was for the tidal washovers in comparison to the rainfall events. And this coincides with other studies where they did simulations between inundations of salt water and fresh water. The location played a really important role in this study, and this could be related to geographic characteristics. For example, here in the Domitian coast, we have the Volturno plain, which has high patterns or intensive and extensive subsidence patterns in comparison to the Alento plain here in Chilento, and this makes it more vulnerable to flooding. Also could be related to the physicochemical parameters because high hatching success is associated with large grain size. And this is not happening in the Domitian littoral coast because they have clay and silt in comparison to the Chilento that we have silt and sand. The relocation was another important variable. We observed a positive effect here in the Domitian littoral coast, which could be associated to the increasing in the distance from the tideline and the reduction of the water saturation and the possibility of water infiltrations. And here we observe like a slight decrease, which could be related to the manipulation. but it was still successful. Here, as I mentioned, we identify that early and late stages are critical for sea turtles, and this match with other previous studies. And precisely, there is one really interesting that mentions that the hatching success is zero when the inundation of salt water and fresh water is right after the viviposition or right before the hatching. But the mechanisms after the death of these two groups can be different. And also in the case of late stage, they could be dying because of an accumulation of events along the incubation period. This high mortality here observed could be related to compound effects of both types of events. We also observed this, that we could not explain very well because it's when the embryos died when there were no events. And this could be associated with early embryo death syndrome, which at the same time is associated with the maternal identity, but this is beyond the scope of this project. Finally, I can say that this project aligns with the conservation priorities for sea turtles and emphasize the necessity or the importance to identify or to contextualize these results to geographic and location frameworks in order to continue with relocation activities and other conservation measures. And I have some limitations with the methodology, for example, because I use only qualitative data to classify the events, which could be improved in future studies using quantitative data too. And the further studies could be associated to identify key traits that are creating these differences between locations, and also if there is an effect on the phenotype and fitness of the hatchlings that already survived with these conditions. And it could be also interesting to determine if there is actually these two groups in the Campania region, And all this to promote more conservation measures with a scientific basis, especially in areas where we don't know so much like these emerging nesting sites. And here is the literature that I use if you want to check it. And thank you so much.
Thanks, Selena. Nice presentation. So again, I'll go to the audience if you have any questions first. Anybody wants to know more? Yeah.
Yes. You said that you relocate the eggs away from the tide line for a better chance of success of hatching, right? But then do you know if it has a deleterious effect on the turtle reaching the sea if they're further away? They're more exposed to, I don't know, like birds.
Yeah, they could be more exposed to, for example, predators, but we did not observe so many predators here in this area because, for example, we did not observe crabs that are really common in other areas. We could say that, okay, seagulls probably, but it was mostly the hatching was during the night.
Okay, thank you.
But there is evidence, for example, that if it's too far from the tide line, probably it's going to be hotter and the humidity also decreases.
Right, and congratulations, it was a really good presentation.
Thanks. Yeah, Daniel.
It is a vague question, but is there any kind of ship protocol in Italy or in the region for these cases of translocation of nest or?
Okay, in Italy you need like a license to manipulate the individuals and to work with turtles. But I could not touch the eggs, to be honest, because I don't have this license. So all the specialists from the Sezione Zoologica and Pandora did it because they have these licenses. And also they follow the protocols of the SWOT and the marine turtle specialists of the IUCN to make these relocations.
Another question?
Thank you so much for your presentation. I wanted to know when you relocate the eggs, it's within the same beach or sometimes the organization takes them into incubators?
Usually it's in the same beach because we try that the conditions are the same. We just try that it's farther from the tide line. In some cases, there are not so many. We have to change the beaches, maybe because there are many establishments in the beach. So it's full of these sandbeds, so it's not possible to lay the egg there. So we try to move it a bit. that we try to keep the conditions. But in this project, 2 of the nests were relocated and they were taken to incubators.
Thanks. So we'll move to the jury members. Whoever wants to start. Next slide. Yeah, thanks, Heather. Hi, Janina. Thanks very much. Your presentation was really good. Just a couple of questions. So in terms of the turtles now moving to like new nesting areas, okay? So we probably assume that, you know, like you said, it could be a spillover or due to climate or, you know, changing really of nest location. But we do know that turtles would nest multiple times during a season. So are these turtles tagged and like, you know, with the metal in the flippers that we would know the individuals if they were nesting somewhere else and then now are nesting in these new areas?
In the project that I was working with, I did not observe that they track them, but I know that there is another project going on that they are doing it. And also in Spain, they tag a turtle, and it was the results show that it nested twice in the same country. No, in Spain.
Yeah, no, normally they would go quite a few times. They can nest like about 4 or 5 times during a
They
season.
can do it in the case of lover. It depends on the species, as you can know. But in the case of loggerhead turtles, we observe between 1 and 3 most of the time.
Because you were saying about having 2 groups of females, and this would definitely give you an answer to that if you know where they are going and where they're coming from. Are they separate or are they dividing their nesting sites in both places? So that's probably something very simple. It is very simple to tag them with the metal tag. So, okay. So in terms of that, could it be that, I mean, these beaches are patrolled at night, I suppose, you were mentioning even
Before the sunrise, yeah.
Yeah, so to look for the nesting females. Could it be that the disturbance of that could be making, the salida falsa, that they are doing that false crawl and then going and coming out actually somewhere else in another beach, and then that became a new nesting area?
Actually, some days ago, we had a video that we observed like a female that went out from the sea and wanted to nest in Mayori, which is a really touristic area full of sunbeds, and there were people recording the turtle and they were like in front. So the turtle face like she feels threat, so they turned again to the sea, but then she tried again and she did it.
Yeah, because they tend to do that. So
but it's important to work there with the stakeholders, because it's amazing to see a turtle. Even me, that I worked in the past with them, when I saw them hatching, it's wonderful.
Yeah.
And you want to touch them, you want to be next to them. So it's understandable that people want to be next to them, but we have to be aware that we also are a threat for them.
Yeah, of course. And just one more thing. So in terms of the stuff that you're considering for the hatching success, like having those events like, tidal events and the floodings and everything, you consider the salinity and the drowning and everything. But do you also think of other factors that could affect, such as the compactation of sand, making it impossible for them to actually crawl out?
Actually, in my manuscript, I know that you read it, I consider, for example, that after tidal washovers, we have this accumulation of sand on the top of the nest. And also strong winds cause the same. And this could be compacted the sand, especially in areas like the Dominican coast, where the grain size is smaller in comparison to Chile. So it's more compacted like cement. Yeah.
Okay, thanks very much.
Thanks.
Question?
So regarding the other factor, environmental factor you can look at, so what would be the next?
Another factor?
Other factor.
I have here supported information for that. Here are other factors, like we could have organic pollution. It's been associated that the hatching success can be reduced if we have more percentage of organic content in sand. And precisely in the Dominican littoral coast, we have site of importance based on the potential of pollution. Because here we have the Volturno River, as I mentioned, like the Volturno Plain, and it's highly polluted, And also we have Regilani, that it was in the past like an aqueduct to reduce the floodings in the Campania plain, but now it's like an open sewage. So it's bringing all the pollutants to this area that could be associated with the reduction of hatching success. Precisely, there are studies in that area in Campania for PCB concentrations and the PFAS. And well, there is something that I mentioned also, the maternal identity, that I could not be able to determine because I did not have the individuals and I did not perform DNA analysis, for example. But it could be associated because there is a concept by these authors that mentions that some females are better mothers than others, and also the things that they transmit to the hatchlings.
Okay, thanks. Okay, one more question. Regarding okay, you look at the success of hatching, so did you collect some eggshell samples to observe them in terms of thickness and also structure? To try to correlate or to see if there is any correlation between the success and...
I did not do it because I could not manipulate the eggs, but part of the project is to conduct stable isotopes analysis, but I'm not sure if they are conducting the study that you mentioned, like for the structure, because it could be related also for calcium, for example.
We have time for one question.
Yes,
okay.
One is, I think there's one factor that possibly should be there, because I was last year on the Ilha do Maio in Cape Verde, which is a nesting ground, and they found that the color of the sand is very determining the survival rate, because they have very dark sand which gets very hot,
yes,
and you have more mortality.
Yeah, it could be.
Do you have this variation in the color of the sand?
I did not consider it in the study, but when I did the nocturnal monitoring in Castelvolturno and the Domitian Littoral Coast in the north area of my study area, it's a bit more dark. But in the Chilean coast, it's really white, the sand. But I did not consider it as part of my variables.
The other question is the hypothetical thing, just see what your opinion is. Do you think for the long-term survival or an increase of the population, is it more important to protect the nesting beaches or to reduce the mortality of the juvenile adults in the sea due to fishing?
That's tricky. Because both the whole cycle, the life cycle is, I think that it's important, at least for me. I worked in the past, for example, with bycatch and sea turtles. So at that time I was like, okay, we have to save the adults and the juveniles. But I think that the part of to protect the beaches is also important, because from 1,000 of the hatchlings, only one became an adult. So I think that it's also important to protect this part.
Okay, great. Nice one to finish on. Thanks very much. So we move from reptiles to fish for the final presentation in this session from Mark. So over to you, and good luck with your presentation.
Hello, good morning. Thank you to my fellow colleagues for presenting the very interesting studies on sea turtles. And I hope I can still motivate some of you here to listen to the boring topic of sharks in the Galapagos. Whereas, yeah, my friend and colleague Lucy and I, we have certainly suffered a lot for the past 6 months being stuck on an island in the Pacific. Her doing very interesting things that I'm not gonna spoil for you. She will present them in the afternoon, but me mostly working with a long-term existing data set of the shark ecology project at the Charles Darwin Foundation. So I will talk to you about seasonal variation of sharks and large predatory fish in Galapagos. So let's start about the purpose of this research, which is often questions that are not sufficiently addressed, especially by us scientists, because we like to say what we have found, we like to say what's significant, what are the numbers, but not so much maybe why we have looked at it in the first place, because for us it seems so obvious, right? So sharks, as I'm sure it's probably obvious for most of you as well, because we're all marine biologists at this point, they have faced a major extinction crisis in the past century, and over the last half century, actually, there's been dramatic declines in global populations of sharks with over 70%. And no surprise that it is mostly the human factor that is at play in this dynamic. And we are threatening global shark populations, not just by overfishing, but also by degradation and loss of habitat and anthropogenically driven climate change. And while at the same time, as it's clear to us, but maybe not to the majority of this world population, we also greatly benefit from sharks, not just on an ecological level, but also personally from a human perspective. It is affecting livelihoods and lives by economic and social benefits, such as from fisheries or tourism. So I want to take you to a special place where I've never seen, well, especially, actually not in person, but on videos. And this is a fate that a lot of us are facing at this stage of our career, and I hope we will progress further and further, and we do reach these places, I'm sure, at some point in our lives, and I hope I can go back and see it with my own eyes. But Darwin and Wolf Islands are located in the very far north of the Galapagos archipelago in the eastern tropical Pacific, and they are, well, the Galapagos Marine Reserve in general is known for its diverse shark populations, but the abundance of sharks within the reserve is highest in this region far north. Darwin and Wolf Islands, they are uninhabited and volcanic islands. And you can, if you go diving there, you will see regular visits of the whale shark, especially in the cold season, and large schools of hammerhead sharks, other blacktip sharks, Galapagos sharks, so on and so forth. So not the worst part to plan your next holiday. And actually, jokes aside, the project team at the Charles Darwin Foundation has found that other than being an exceptional place within the Galapagos Marine Reserve, Darwin and Wolf Islands, they were found to host the largest reef fish population in terms of biomass worldwide. So obviously this is only what has been reported until this day. So this is has not been exceeded since 2016. And this largest reef fish biomass is mostly composed of sharks, large and highly mobile sharks. And lastly, the question of seasonal variation. Why do we hypothesize there to be seasonal variation? This is mostly driven by the unique and dynamic oceanographic setting of the Galapagos Marine Reserve, which is influenced by three major ocean currents, the Cromwell Current and the Humboldt Current, bringing cold waters from the west and the southeast, and then the Panama Current bringing warm waters from the northeast. And these currents, they actually alternate in strength throughout the year, giving rise to two distinct seasons, namely a warm season spanning from January to June, and a cold season from July to December. And here at the top, I have mapped for you the mean sea surface temperature of the months where the sampling has been conducted, which were in the respective middle of the warm and the cold season, so March and August. Leading back to the research that I've done, and with a special focus on the application of this study, because in the end, the purpose is to develop more effective conservation and management strategies for this hotspot of sharks, not just locally of importance, but also globally. And specifically, I have looked at how the predatory fish assemblages vary between seasons, so the warm and the cold season, which species are driving this variation, and does this variation homogeneous in this area, or does it vary also on a small scale between and around the islands? My methodology has followed 3 main steps: the field sampling, video analysis, and data analysis and visualization. For the field sampling, the shark ecology team at the Charles Darwin Foundation employs 2 main techniques of underwater video collection, namely the remote baited underwater video, also known as BROV, and the in-person diver-operated video, also known as DOVE. And together they give a more complementary view on the whole predatory fish assemblage. The videos that are collected in the field are then analyzed back at the station using a specifically designed software called CGIS, and have then been put to the test by multiple univariate and multivariate analysis, and the statistical and data manipulation software we're all very familiar with right now, leading to or focusing, going back more now in the details of the methodology. So I'll start with the BROV, the baited remote underwater video. These are constructed by a set of cameras, so 2 cameras in housings that are mounted on a triangular steel frame and pointed towards a canister of bait. In this particular example, it's a yellowfin tuna that's been chopped up to attract the sharks. So already we are narrowing our sampling, or we're targeting very clearly towards high trophic level sharks and predatory fish by using this bait. And this structure can be deployed at different levels within the water column. And specifically, the shark ecology team at the foundation is deploying them mid-level and at the bottom. So both pelagic and benthic species can be sampled. And again, this would give a more complementary view of the whole fish species assemblage, not just at one habitat, but at within the whole water column. And here's a special treat for you. I hope that the video will work. I'm not sure which key to press, but I'll try with my very useful assistant. So this is footage from Darwin Island in the far north of the Gulf. Very curious Galapagos shark that checking out the tuna sandwich. But to know success, and this is also where the video can be set. I'll try. Yeah, okay, I do have control. So that's reassuring. Next, the diver-operated video, which is conducted in person by 2 qualified divers. The first one will have the camera set up in their hands and follow a 25-minute dive transect along the same depth gradient. And a second diver who will record the location and the track using a surface buoy at the carrying a GPS tracker. And again, for you to have more of an idea what footage we then get to look at back in the office. This is, okay, no, it was the wrong key. Can you please start the video? This is also footage from Wolf Island, where you can see a school of hammerhead sharks in the background. I assure you it's not all of the footage is as exciting as this, but I try to give you a bit of a show. And other than sharks, you can see there's lots of schooling reef fish. We try to standardize the video in that way that approximately 1/3 of the frame will focus on the reef, and 2/3 of the frame will focus on the water column. So again, to try and get a mix of pelagic and benthic species. And back in the office. This is the software that we're using, CGIS. As you can see, you have the footage from both cameras because this is a very important aspect of stereo video, that you can not only record relative abundance with it, but you can also calibrating these two videos and knowing exactly the measurement of the setup, you can calculate the size of the individuals. So this is like for follow-up, for a long-term study, very important to also calculate biomass and density of individuals. And if you quickly want to play that video as well, just to give you a water quiz, I will show you the notion of it. And here the black measurements are done. Footage on the left and the right camera, and you type in each, and it is then recorded within the database, and this can be extracted to Excel, manipulated there, and then further exported into R for statistical analyses. Fasting forward, the results that you get after looking into these statistics is that basically, and maybe without surprise, thinking about the strong differences in temperature between seasons in the Galapagos that I have showed to you before, there is a strong seasonal variation in sharks and predatory fish. On a more general level, mean species richness and relative abundance are both significantly higher in the cold season. And not only season, but also orientation around the islands had a significant effect on the variation in fish assemblage. So thinking back of how the currents come from different directions, it does come to, link back to the hypothesis at the beginning, and narrowing it down on a species level, there are specific drivers of the seasonal variation, and these were namely highly mobile sharks and carangids, or jack species. This is the scallop hammerhead shark, the silky shark, and 3 species of carangids. And I want to tell you a little bit more about what this means and what we're going to use it for. So both sharks were significantly more abundant in the cold season, and they're important because of their listing on the International Union for the Conservation of Nature, the IUCN Red List. So they're both threatened by extinction. And in the Galapagos, they are exposed still to bycatch and small-scale fisheries and illegal fishing, whereas they're also highly migratory, so they're exposed to threats and industrial fishing outside the reserve boundaries. Whereas the carangids as well were more abundant during the cold season. This is probably used to related to prey availability and important to consider, since they are of commercial value to the small-scale fisheries within the reserve. So again, linking this back to implications for the reserve management, this study has only provided a small glimpse on seasonal variation, but I'm hoping that it can be used in the long term, especially as a baseline for long-term monitoring data, where this small-scale temporal seasonal variation is important to interpret population trends over longer time, especially if we think about impacts from fisheries and climate change. So this is the first implication for management. And then secondly, considering the ecological and the commercial value of the species that are driving the seasonal variation and how they're significantly more abundant during the cold season, hopefully this will lead to the development of temporal management strategies where, for instance, fisheries can be restricted or enforced better during the cold season. So, for instance, illegal fishing might be reduced due to higher enforcement of this very remote, far northern part of the reserve, and thereby this unique hotspot of shark and large predatory fish diversity and abundance can be preserved and for future generations. Thank you.
Well done, Mara. Definitely as interesting as the reptiles sonores there. So do we have questions from the audience first? Maybe, yeah.
Hi, thanks for the presentation. I'm not a shark person, so I find it very interesting, but I do have some confusion or questions rather. Correct me if I'm wrong, the sampling for recording the species of sharks was mainly based from the the video recording. Yeah, I'm just curious if there's a part of the analysis that would prevent the idea that the sharks that has been recording for a certain time period is not the same shark, it's like circling around. And are these results also comparable to other islands, at least with the same latitude, where temperature is driving the differences, if I understand it correctly? Yeah.
Okay, great questions. Yeah, so there are always lots of biases with methodologies, and especially cheap and available methodologies such as underwater video, right? It's, well, the BRAV is remote, the DOV is directly by divers, but one or the other, it's a cheap way to assess in the long-term populations in marine reserves. And also across the Pacific, actually, it's widely used. So for instance, comparable MPAs in the Eastern Tropical Pacific, such as the Cocos Islands, that belong to Costa Rica, the Malpelo Island, which belong to Panama, they're also employing the same methodologies. So this is relating to your second question. And then the first question, so this gets very complex because in the end I have used different methodologies with different biases, but looking first at the BRAV, we are deploying a camera or a camera set at different locations for a time span of 90 minutes. So of course we need to make sure the animals are actively attracted to the bait so that we don't record the same animal twice. And this is done by not measuring total abundance. So we don't measure the total abundance of individuals that we've seen, because it could just be the same individual coming back and forth. We are measuring the abundance in terms of relative abundance, max N. So this is a specific measure that underwater video and BRAV, basically remote under video, employs, where the maximum number of the same species recorded in one frame, that counts as the relative abundance of that species. So for instance, I'm going to try and explain a bit more. I have a camera set up here, and Leia, she is really attracted to the, I don't know, tuna sandwich, and she's coming back and forth maybe 5 times. But it's just one species of Leia. Then there's a school of 2 mans, and maybe they're checking out the bait once, and then they leave. And then there's a school of 3 mans, and they're checking out the bait, and the school of 5 mans, and they're checking out the bait. So the final relative abundance that is measured is 5, because that's the total. That's the maximum number of individuals that were captured in the same frame. So we make completely sure that we're not sampling the same individual. And then for the dive-operated video, which is not stationary, it's moving along a transect. So here we make sure that the camera is like continuously facing forward, and considering the swimming speed of most individuals, like you've seen, for instance, the hammerhead sharks, actually they were not that fast. So when you follow the transect, you can, by the way that you are moving, the diver is moving along a transect, you already reduce that bias substantially by not capturing the same individual more than once, because also you're not baiting them, so you're not attracting them, you're just passively following this transect. Yeah, so it's a whole world talking about biases of remote sensing and underwater video in general, but definitely a lot to discuss there.
Thank you.
Nicely explained, thanks.
Another question?
Thanks so much, Mark, for your presentation. It was really interesting. My question is somewhat related to his question. So I was also doing RUB, so I studied with just max n, so all of my analysis just use this one single parameter, right? But now my understanding is that you're using two different parameters with, like you said, two different biases, and they refer to different count data, right? So how are you sort of using it in your analysis? Like, are you bringing it to like a sort of, like, are you comparing between the two, or is it you do two separate analyses, two different parameters? Are you bringing it to some sort of middle ground to understand?
So a classic way of underwater video is the RUB. So yes, that is the measure max n that I have just explained, and a lot of previous studies use it. But because of species-specific differences in behavior, and we're mostly, with the highest interest here, we're looking at sharks. And also what you could have really nicely seen on the videos is that different species of sharks react differently to different techniques. So for instance, the broth, the bait, there are more scavenging species that might approach this bait, like the Galapagos shark in the broth video. And then there's the hammerhead shark that you've seen on the dove video that like does not care about the diver, but it's just passing. And for instance, this hammerhead is rarely recorded in broth because it's not actually attracted by it. So even though we lose resolution of data because we use two different measures, we use max n for the broth and we use the measure of another relative abundance for the dove. Since I was trying to look at the whole species assemblage, I have analyzed them separately and then brought together at the discussion level, because they could be standardized as presence-absence, and that way they would be kind of comparable, but you lose so much resolution there. So this is a whole different section talking about the different methodologies, but yeah, well, I think well said, since you were looking at broths as well.
No, thank you. I was just curious.
Yeah.
Thanks. So we'll move to the jury for a question.
Okay. So how many years of data do you have?
This is a great question. And it's a major limitation of the study, since it is only 1 year. So I have, as I said, I have the measurements from March and August. And this was not, well, obviously not taken from this year, since I cannot go to the future, but from, oh, I forgot to thank you, sorry. This was my last day. From 2017, because actually this part of the Eastern Tropical Pacific is highly affected by ENSO. So the El Niño Southern Oscillation, for those of you who don't know. So there's like strong climatic abnormalities with warmer temperatures during El Niño and colder temperatures during La Niña. And that's why, well, in general, long-term monitoring sets or data sets have so much value, but especially in locations like this, where the species are already subject to such high variation in temperature, it is important to then look at a year. So in this study, we looked at data from 2017, which was, well, like in terms of temperature variability, relatively normal, so no abnormalities from La Niña and El Niño, but that again also very much reduces the temporal replication of the study, because then we only have 1 year. And in the future, hopefully there will be more data to then look at more years and compare them. But then again, there's I guess the decline from other factors that we have to consider. So if the next climatically normal year will be in 2 years, that's already almost 10 years from the last sampling. So then how much of it is really related to season and how much is related maybe to climate change or fisheries impact and other threats? But yeah, it's a major limitation, and hopefully will be complemented by long-term data analysis in the future.
So you focused on these reef-associated species on these fairly remote islands, and you see these seasonal differences. Where do you think they're going or coming from? I mean, how wide is the species assemblage change?
So I think this is very important in the way that I have, like, my main aim was not just to look at variation and does it change, but who's driving the difference. So really clearly identifying the species to focus on, because in the end, I guess we do need to focus in conservation, always in management financially. I mean, we have so many constraints. So that's why it's interesting to identify especially the scalloped hammerhead shark and the silky shark as species of high conservation interest. And there are other studies at the other oceanic MPAs that I already mentioned to my colleagues that are investigating also the long distance migration. So these species are highly migratory, and they have interestingly both very different migration routes. So the scalloped hammerhead shark has a seasonal migration that has been described up to the continental coast of South America. So this is related to reproduction. Whereas the silky shark, there's really not a lot of data on it, but it's traveling in the opposite direction towards the international waters of the Pacific, where it's especially vulnerable to industrial fishing fleets and especially from tuna fisheries.
Are they doing any telemetry to test this?
Very good question. I don't know if I can. This is if you can. It's a video. If you can start it.
You might have lost the video.
Sorry.
It's multitasking.
So, very new study from last month was published by my principal investigator. They've tagged the silky shark at Wolf Island, and they have recorded the longest ever migration of a silky shark, thousands of kilometers west of Darwin Island into the international waters of the Pacific, where it's, as I said, highly vulnerable to industrial fishing fleets, which are not even only operating in these areas beyond national boundaries, but also within the exclusive economic zone of Ecuador, around the Galapagos, and then other states along the continent. But yeah, this was not, it's really the next step in this kind of analysis. So we know they're more abundant during the cold season in the reserve, and we have kind of an idea, okay, there's a lot. It's important to conserve and manage them while they're there. But where do they go when they're not there? Where do they go when they're out of sight, when they're vulnerable to fisheries and bycatch? So yeah, always complement this kind of stationary, geographically limited studies with long distance migration or tagging studies, although these will then have substantially lower replication. Yeah, as we have heard from my colleague, there you are, for tagging studies, how the financial constraints and the logistical challenges then reduce sample size substantially. So,
thanks. We have time for one more question. Yes.
You were talking about you were talking about the measurement of the shark in your methodology.
What?
You were measuring shark.
I said that. Yeah.
So how do you integrate the distance to the camera of this measurement?
I said that that's an area to explore found in the following studies. So this will be further explored. So now I've looked at the relative abundance. Yes. One of the main promises of this technique is that in the future we can also look at size and biomass of individuals, but it's got nothing to do with the distance. Well, obviously the size of the individual is measured by the calibration of the videos, but we don't look at how far the individual is away from the camera. That's not really of interest. Of interest is how large are they and how is the size distribution throughout the year, comparison, and also following years, how does it change?
Okay, but regarding this size, so is it not more accurate? And because to remove this bias of distance, is it not more accurate to measure the size of the fins or the area of the fins that can give you, I mean, if you have to measure the highest part and the
yeah.
width.
As I said, this is
that give you a clear. The ratio will give you a more clear. I don't know if you get any data about the shark that's just measuring the length.
this is not part of my study. It will be a follow-up study, but there are existing size length measurements, ratios of species. So these are available from data tools online, such as FishBase, as I have used in the classification identification of species. And from that size measurement, you can then calculate biomass. So a 3D image of the individual, let's say, in terms of quantitative data.
Okay, thank you. Then, so I suppose it's not exon?
No, it's not.
It's not? So
that's where I was talking about small-scale fisheries, how you...
Sorry, I missed it. And do you know, do you have any idea about the growth rate of the population of, I mean, the different shark population there?
So this is the small-scale temporal snapshot of seasonal variation, which will feed into the analysis of long-term monitoring data over the course of 10 to 15 years. So this is taken from a sampling campaign that has started in the early 2000s and is soon to be finished, and I'm sure there's going to be a nice PhD project available, hopefully, where they will then look at the long-term...
Yeah, but I mean, it's a zone that is overstudied, and I think that some scientists have done some work before regarding all this population. How can you, so what did you bring to this other study, and what do they know about all this shark diversity there?
I would not agree that this area is overstudied at all. In fact, I was the only one, the first one who looked at seasonal variation of sharks and large predatory fish in this area. And the reason and where it all ties together, I guess also on the management and political dimension, is that scientists are trying really hard, or people from the station are trying really hard to declare it as a no-take area. So this is where different studies will hopefully build into a more scientific evidence base to support and defend these claims. But it is definitely not overstudied. Yeah, maybe just leaving it at that. But this is the first study that looks at seasonal variation, but which for me also seems crazy because it's so interesting and there's lots more to do. So yeah, glad that we're all graduating soon and
you're out there to do it. Waiting, hopefully. Okay, very good. Well.
So that concludes our session. We have a break now for lunch for an hour and a half, and the next session starts at 2 p.m. So as you run off, I'd like to thank all, say well done to all three speakers.